Hi guys, this is Larry again, and today we're going to be talking about Fryette's laws. So Fryette had three laws. The first law pertains to type 1 somatic dysfunctions. The second law pertains to type 2 somatic dysfunctions, both of which we'll explain in a second. And the third law, which technically wasn't written by Fryette, but a guy named C.R. Nelson, talks about the ways that the vertebrae moves in different planes. That one we're not going to talk about today. We'll just talk about the first and the second law. So when we're talking about Fryette's laws, we're talking about the ways that the vertebrae move, specifically the vertebrae of the T-spine and of the L-spine. When we talk about Fryette's laws, we generally don't talk about the C-spine. The reason is because the C-spine actually works by a little bit more complex way, and Fryette's law number 1 and 2 doesn't fully explain the way that the C-spine moves. So you'll learn that later on the semester or later on the year. But for now, Fryette's laws apply for the T-spine and the L-spine. So let's talk about the type 2 somatic dysfunctions first, or Fryette's law number 2. Fryette's law number 2 describes the motion of a segment, or a type 2 somatic dysfunction. A type 2 somatic dysfunction means that this somatic dysfunction really just affects one, and some people say two segments, but it doesn't affect a group of segments. Okay, and when we name type 2 somatic dysfunctions, what we first do is we name the name of the vertebrae. So let's say this is the T3 vertebrae right here. So we'll first say T3. We're gonna say if it's flexed or extended. We're gonna say how it's rotated and how it's side bent. And I'll get to what that means in a second. So the first thing is you always name the vertebrae. In this case, we're talking about the T3 vertebrae. We're going to talk about if its freedom is in flexion or extension, which I'll get to that in a second, and whether or not its freedom is in rotation or in side bending. So what do I mean by the freedom? So let's look at this T3. Right now, let's say you're palpating a partner and you feel his spinous process. Now, you take your thumbs, your left thumb and your right thumb, you go a little bit lateral on both sides of the spinous process, and you push down on those TPs, which are right next to the vertebrae, okay? And let's say here on the left-hand side, you feel that this TP right here is a little bit more posterior. It's a little bit closer to your thumb than this TP here is on the right. Okay, what that means is that this entire vertebrae is rotated towards the left. And when it's rotated towards the left, we call that the freedom. So this T3 right here, this segment, is rotated towards the left. Now we're going to do the same thing, but instead of talking about rotation, we'll talk about how it side bends. And when it comes to type 2 somatic dysfunctions, side bending and rotation always happens in the same direction. So if you knew that this rotation is towards the left, you know that the side bending is also going to be towards the left. And what do I mean by side bending? Side bending would be like if this entire vertebrae, if it was trying to side bend this way, like the entire thing is moving on an AP axis towards the left, or if it's moving towards the right, kind of just bending over towards the right, what you'll notice is that it's going to side bend better towards the left, because in type 2 somatic dysfunctions, the rotation and the side bending will always be in the same direction, at least for OMM like test taking purposes. They're always going to be in the same direction. So if we know that's rotated left, we know it's side bend left. Finally, we want to know if this segment is flexed or extended. We want to know if it's in its freedom, if it's flexed or extended. So what do I mean by that? So what you tell the patient to do is you tell the patient to flex, and you feel the transverse processes again. And then you tell the patient to extend, and you feel the transverse processes again. Let's say you feel that when the patient's extended, you still feel that the left-hand side is a little bit more posterior and the right-hand side is a little bit more anterior. But when the patient flexes over, you feel that, they went back into symmetry. What that means is that the flex position is going to be the freedom. And we would name this a T3 flexed, oops, a little problem there, T3 flexed, rotated left, side bent left. So that particular segment, that's the way we name it. We always say which segment, we say whether or not it gets better in flexion or extension. So if it gets better in extension, we call it extended. If it becomes more symmetrical in flexion, then we call it flexed. We see which way it's rotated, and once we know that, we also know which way it's side bent. But you can always test for side bending if you want it to, but side bending and rotation will always be in the same direction. Now, a lot of people forget that flexion and side bending are always in the same direction. So a little trick you can use is if you think about the letter F, or you think about the letter E, if you were to draw arrows on the ends, the F and the E are always going to be in the same direction, right? All the arrows are in the same direction. So you remember that rotation and side bending are always the same direction. And that's going to be for a type 2 somatic dysfunction, and that's with Fryette's law number 2. Now, when we talk about Fryette's law number 1, we're talking about a group curve. So instead of talking about just one segment like T3, we might be talking about the segments T1 to T3. So let's imagine right now we are examining T1, T2, and T3, and we find that there's a somatic dysfunction there. So when we name it, we're going to name it through the range of all the segments that it involves. So we're going to name it T1 through T3. Now, instead of it being flexor extended, type 1 somatic dysfunctions are always going to be neutral, meaning that if you flexor extended, the somatic, like you're not going to see the symmetry, the asymmetry go away. So we call group 1 or group curves or type 1 somatic dysfunctions, we call that a neutral curve. So instead of writing flexor extended, we say T1 to T3 neutral. And we want to know how it side bends and rotates. For this one, it's really important because you want to make sure that side bending, you write the side bending before you write the rotation. The reason is because, according to Fryette, side bending precedes rotation, meaning that after you find a side bent segment or a group of segments, they will rotate in order to compensate. So this happens to be for things that are more compensated. The group curves happen to be for more chronic somatic dysfunctions. And the side bending happens first, and then the rotation follows it. So when we write it, it's convention to have side bending first, and then rotation. Now, let's imagine that when we did the rotation, we felt that the right side here is a little bit more posterior, but the left side here is not as posterior, it's a little bit more anterior. That would mean that the freedom of this segment right here, T3, and let's say for all T1 through T3, the freedom is rotated right. So we know that the R is rotated right. Since we know that the R is rotated right, we will then know that the S, the side bending, is going to be side bent to the left. The reason is because group 1 somatic dysfunctions, type 1 somatic dysfunctions, those are always going to be in opposite directions. So with the F and the E here, we said those were always in the same direction. The way to remember the way side bending and rotation works for group 1 somatic dysfunction is to think of the letter N, like N for neutral. The N are in opposite directions, right? If we were to draw arrows. So the side bending and rotation are going to be in opposite directions for group 1 somatic dysfunctions, okay, or type 1 somatic dysfunctions. So Fryette's laws talk about how vertebrae move. Fryette's law number 1 talks about group curves. And when we talk about group curves, we're talking about a group. It's always going to be neutral. Side bending will always precede rotation, and they're always going to be in opposite directions. When we talk about type 2 somatic dysfunctions, instead of talking about a group curve, we're only talking about one particular segment, and that particular segment is going to be flexor extended, and it's going to be rotated and side bent towards the same direction. Okay, and if you guys have any more questions, make sure to email me. Again, my email is lhuang3@student.turo.edu. Thanks a lot, and see you for the next video.